Hello everyone, welcome to all of you. Today we are going to start our new lesson towards green energy. Students, in modern civilization, energy has become a primary need along with food, clothes and shelter. We need energy in different forms for different types of works. The energy that we need may be in the form of mechanical energy, chemical energy, sound energy, light energy, or heat energy. Now you must start thinking that how do we get these different forms of energy, right? Now you know that energy can be converted from one form to another form. Different sources of energy are used to the different forms of energy necessary for us. Now we have already learned in previous standard that sources of energy and various concepts related to them. Here in this chapter we are going to concentrate on various sources that are now used for the generation of electrical energy, the methods that are used for this purpose and the scientific principles that are used there, and the advantage and disadvantages of these methods, and also what is meant by green energy. Generation of electrical energy. Most of the electrical power plants are based on the principle of electromagnetic induction, which is invented by Michael Faraday. According to this principle, whenever magnetic field around a conductor changes, a potential difference is generated across the conductor. The field around the conductor can be changed in two ways. If a conductor is stationary and magnet is rotating, the field around the conductor changes, or if a magnet is stationary but the conductor is moving, then also the field around the conductor will change. Thus, in both these cases, a potential difference is created across the conductor, as you can see here in this first picture. The electrical power generating machine based on this principle is called as electric generator. Such large generators are used in commercial power generation plants. Turbine is used to rotate the magnet in the generator. A turbine has blades. When a flow of liquid or gas is directed on the blades of the turbine, it rotates, as here you can see in the second diagram, because of the kinetic energy of the flow. This turbine is connected to electric generator. Thus the magnetic electric generator starts rotating and electric energy is produced. This method of electric energy generation can be represented below. Now this is the schematic of electric generator. As here you can see that to generate electricity based on the principle of electromagnetic induction, we need a generator. To rotate the generator, we need a turbine, and to drive the turbine, we need an energy source. Based on which type of energy source is used to rotate the turbine, there are different types of power generating stations. The design of this turbine used in different types of power stations is also different. Now here you can see the flow chart showing generation of electrical energy. That proper energy source to run the turbine which is required and which is reaching towards the turbine. Then turbine is connected to the generator and how the electrical energy is generated from the generator. Thermal energy based electric power station. Here you can see in the diagram, or you can call it as a flow chart, that turbine is rotated using steam. Water is heated in a boiler using the thermal energy released due to burning of coal. Steam of very high temperature and pressure is generated. The energy in the steam drives the turbine. Thus the generator connected to the turbine rotates and electrical energy is produced. the steam is converted back into water and the water is recirculated to the boiler again. This is shown in the flow chart, which you can call it as a flow chart showing generation of electrical energy using thermal energy. Here you can see the flow chart for energy transformation in thermal power plant. As in the starting, chemical energy in the coal is converted into thermal energy. Then this thermal energy is going to the kinetic energy in the steam. The kinetic energy in the steam is converted into the kinetic energy of the turbine, and then the electrical energy is generated. As here in the schematics of thermal power plant, you can see that after combustion of fuel, that is here which we have used coal, in the boiler the emitted gases are released to the atmosphere through very high tower. Once the turbine is rotated using the steam at high temperature and high pressure, steam temperature and pressure decreases. This steam is converted back to water by taking out heat from it. That is by cooling it. This is done in the condenser using water in the cooling tower. The water is cooling tower is circulated through the condenser. Heat energy in the steam is given to the water and the steam condenses back to water. The heat absorbed by the water is then released to the atmosphere through vapor and heated air through cooling tower. Although thermal power generation is a major way of electricity generation today, it suffers from certain problems, which we are going to discuss in the next slide. Some environmental problems related to this thermal power plant are like air pollution, water pollution and groundwater degradation, land degradation and soil pollution, noise pollution and thermal pollution. As here air pollution due to burning of coal results in emission of gases like carbon dioxide, sulfur dioxide and nitrogen oxide, which are harmful to the health. Along with the emission of gases due to the burning of coal, soot particles are also released into the environment. This may cause the serious health problems related to the respiratory system. The reserves of fuel used in this method, that is coal, are limited. Therefore, in future, there will be the limitations on the availability of the coal. Thank you so much. Have a nice day. Take care and stay safe.